Hello viewers, this is Ronald taking you through the story of A-level applied mathematics. And this video I'm going to go through the topic of continuous random variables. So this topic is under the part of probability and is suitable for students in both senior 5 and senior 6 of rank principal mathematics. So a continuous random variable is a theoretical representation of a continuous variable. Now that word continuous variable. So previously we covered discrete random variable and we saw that those discrete random variables take on whole numbers like 1, 2, 3, 4, 5, etc. But now these are continuous, they take on all the values including decimal points within a given range. So that means that the probability space or the possibility space of a continuous random variable is infinite, from negative infinity to positive infinity. Now this topic is subdivided into 3 parts. So the first one is called continuous probability distribution function. In short, it can be called PDF to mean probability distribution function. Then the second part is continuous cumulative distribution function, or you can call it CDF. And lastly can be called rectangular distribution function or uniform distribution function. So we shall start with continuous probability distribution functions. And we shall say that this is a function whose random variable, say capital X, takes on values within a given range. And this function allocates probabilities to all the ranges of values that the random variable can take. So now we shall start with individual probabilities. So in probabilities under continuous PDF are got by integration. So always remember that as long as it's a continuous PDF, probabilities must be got by integration. And also remember that unlike for discrete, for continuous, these symbols mean the same. The symbol for less or equal to and the symbol for less than means the same, and also the symbol for greater than or equal to or greater than, they also mean the same. Just as you can see here, all these probabilities, they all mean the same irrespective of the inequalities. For example, here there is a x greater than 1, also here x greater than or equal to 1, but these inequalities mean the same. And here there is x less than 2 and also here x less or equal to 2, but they mean the same because it is under continuous PDF. And they, like we said, they are got by integration. So you have to integrate the given function with respect to the variable, which is x, from the lower limit to the upper limit. Now these limits are got from the given required probability, or the probability which is us. Like in this case, that's for the probability of values from 1 up to 2, meaning that you have to integrate from 1 up to 2. So with that concept, let's see how this question can be answered. So question 1 says the probability distribution function is given as, so this is the function, and this is the range of values for which this function is valid. Otherwise, outside this range, the probability is 0. That's what this 0 elsewhere means. So they want you to find Roman 1, the probability of x greater than or equal to 1 but less than 2, and Roman 2, the probability of x less than 1.5 given x greater than 0.5 has already occurred. Then Roman 3, they want the probability of x greater than 0.5 given x greater than or equal to 0.25 but less than or equal to 1 has already occurred. So Roman 2 and Roman 3 are conditional probabilities. So the first thing to do is to remember the definition of probability that you have to integrate. So this probability is got by integrating from 1 up to 2 of fx. Now in the question, fx was given by this function, therefore that's what we're going to integrate. But you cannot integrate this when there's a product in between these two variables. So what we are going to do, we are going to first put the x inside the bracket. So when I put it inside the bracket, I'll come up with 4x minus x cubed. Now this quarter is a constant, meaning it can come outside the integral sign. The next is to integrate. When I integrate 4x, I come up with 4x squared over 2. Why? Because I have to increase the power by 1 and divide by the new power. Then when I integrate x cubed, I come up with x power 4 over 4, still the same concept. Increase the power by 1, divide by the new power. Then this quarter is still maintained. Now next is to substitute the limits. So we begin with the upper limit. Where there is x, put there the upper limit, which is 2, to come up with this bracket. Then next is the lower limit. Where there is x, we put there the lower limit, which is 1, to come up with this bracket. The next is to use a calculator. The whole of this bracket gives you 4, and the whole of this bracket gives you 7 over 4. And when I simplify further, I'll come up with 9 over 16 as the required probability. So basically that's what they wanted in Roman 1. Now let's see how marks can be awarded. So M1 for the correct definition of probability, M1 for integration, M1 for substituting the limits, and A1 for the output. So now we shall go to Roman 2. Roman 2, they wanted the probability of x less than 1.5 probability of x less than 1.5 given that x greater than 0.5 has already occurred. So like I said, this is the conditional probability. For example, if you remember under probability theory, the probability of x given b is expanded as probability of A intersection B in the numerator divided by the probability of B in the denominator. So what does that mean? It means that the numerator must have the intersection of these two inequalities. So the first one is x less than 1.5, so where there is 1.5 and less, so it goes this side. Then we have 0.5 greater, so greater goes this side. But they want the intersection. Intersection means the range which is shared by both. So if you look at this, it is this range which is shared by both, and it starts from 0.5 and ends at 1.5. That is why you see here numerator, you see the probability of x greater than 0.5 but less than 1.5 because of this intersection. So the numerator has to be the intersection of both inequalities. Then the denominator will be the one after the slash. So then from there I remember the definition of probability, that is got by integrating fx from using the given limits in the probability. So in this case the smallest is this, so it will be the lower limit, and the highest is this, so it will be the upper limit. Then for the denominator they gave us only one value, and this is x greater than 0.5. What does that mean? It means that x 0.5 is the smallest, so it becomes the lower limit. Now the maximum, if you look at the given question, the maximum value of the range is 2, because the range in which the function is varied is from 0 to 2. Therefore here the upper limit, you put the maximum value, which is 2, and this 2 is got from the question. So we are going to integrate still fx. After that we shall now integrate. So when I integrate, this gives me that and this gives me that. So it is still the same integral. The output is still the same because it is the same function being integrated. Similar to that one in Roman 1. What is changing are the limits. So next to substitute the limits, you start with the upper limit to put where there is x, you put 1.5 to come up with this. Then after that you get the lower limit where there is x, you put 0.5 to come up with that. For the denominator where there is x, you first put there 2 to come up with this. Then after that, where there is x, you put there 0.5 to come up with that. After that, we shall use the calculator. The whole of this bracket gives you 207 over 64, and this bracket gives you 31 over 64. For the denominator, this bracket gives you 4, and this bracket gives you 31 over 64. So when I divide the two, I'll come up with 176 over 225. So basically that's what they wanted. Now let's see how marks can be awarded. So numerator and denominator, and integration and substitution. So integrating and substituting on the numerator, that is m1, also integrating and substituting the denominator, that is also 1. Then another m1 for this division and a1 for the output. So now we shall go to Roman 3. So Roman 3, still there is this slash, meaning it's a conditional probability. So the numerator must be the intersection and the denominator will be the one after the slash. So how do they get that intersection? You try to draw something like a number line, because you know that 0.5, they want x greater than 0.5, so it has to go that side. Then next, this other probability is values ranging from 0.25 to 1. So if this is 1 and 0.25 is this side, 0.25, the range is this. So what does that mean? That the intersection of this and this inequality is here. That is why we are, so the values start from 0.5 to 1. That is why you see here 0.5 to 1. So after getting the intersection, next is to remember the definition for probability, that you have to integrate the given function using the limits given in the probability. So for this probability, this is the smallest, becomes the lower limit, highest becomes the upper limit. Similarly, smallest becomes the lower limit here, highest becomes the upper limit. So next, after that, we shall integrate. So when I integrate, we have already integrated this in Roman 1, so the same integral. Next is to what is changing are the limits. So we are going to substitute first 1 to come up with this, then substitute to 0.5 to come up with that. That is for the numerator. For the denominator, substitute 1 to come up with that, then substitute 0.25 to come up with that. So when I simplify, I realize that the probability required is 144 over 185. So basically that's what they wanted. Now let's see how marks can be awarded. So this m1 is for this numerator, m1 is for this denominator, m1 for the division, a1 for the output. So that is individual probabilities. Hope you have mastered that part of individual probabilities. Now we shall go to part B, which talks about total probabilities. So what do we need to know in this part? So in this part we need to know that total probability must always be equal to 1. So always remember that. That means that the integral of fx for all values of x will be equal to 1. So the special case is that for graphical approach, if fx is linear, so sometimes fx can be linear or non-linear. So if it is linear, you can still use a graph to show that total probability will be equal to the total area under the graph. So if as for the total probability, you can get total area under the graph and it also be equal to the total probability. So what is the essence of this? So the essence is that this concept of total probability being equal to 1 is used to get the value of an unknown constant. So in question 1, the function did not have an unknown constant, but sometimes they can give you a function with an unknown constant. Just as you see in question 2, the function is kx, and they said find the value of the constant k. So in this case, for you to get this unknown constant, you have to remember the concept that the probability is equal to 1. So let's see how question 2 is done. So the first thing to do is to remember that total probability is equal to 1. Therefore, when I integrate fx for all values of x, I must be able to get 1. The fx was kx, so you come and substitute for fx. Then after that, the limits go from the given question. The given question was that this function is varied for values of x ranging from 0 to 2. That is why we put there 0 to 2 as our limits. The next is to integrate. When I integrate, remember this is a constant, can come outside. So when I integrate x, I come up with a half x squared. Then substitute the limits. Where there is x, we put there 2 to come up with this bracket. Where there is x, to put 0 to come up with this part, which is 0. The next is to use a calculator to simplify. The whole of this box bracket will be equal to 2, but there is k here, to come up with 2k equal to 1. But they want the value of k, therefore k will be equal to a half. So that is one way of getting the value of the unknown constant, and it's used most frequently if the function is non-linear. But in this case, the function was linear because the only highest degree was 1. Therefore, if the function is linear, you can either use this method of integration, or you use the alternative method of using a sketch graph. So in this method, we are going to first sketch the graph of fx. So for you to sketch the graph, you have to know the axes. Horizontal is x and vertical is fx. Then from there, we shall realize that when x is 0, fx is also 0, and when x is 2, fx is 2k. Why? Because the function of fx is xk. Therefore, when x is 0, k times 0 is 0. That's why there is 0 here. But when x is 2, k times 2 gives you 2k, which is there. So after drawing this graph, you remember that total probability is the same as total area under the graph. So if you look at this area under the graph, it forms a right-angled triangle. Therefore, I have to remember the formula for area of a right-angled triangle, which is a half base times height. So in this case, the base is 2, which is that, and the height is 2k, which is that, and that is a half. But you should remember that it should be equated to 1. So in that case, I realized that this 2 and this 2 can cancel to remain with 2k here, which is equal to 1. Therefore, k is equal to a half. So basically, that's what they wanted. Now let's see how marks can be awarded. So M1 for the definition of total probability, M1 for integration, M1 for substituting limits, and A1 for the value of k. That is if you use the method of integration. But if you use graph work, B1 for axes well labeled, B1 for the graph well labeled, M1 for definition of total probability, whereby total area is equal to 1, and A1 for the value of k. So that is part B, which dealt with total probability. I believe you have mastered that concept. Now we shall go to the next concept of part C, which is mean or expected value of x. So expected value of x is denoted as ex. So when you see this symbol ex, just know that they mean expected value of x. Therefore, it is given by the formula that ex is equal to the integral of x fx with respect to x. So this x gives you that x there. So you should remember that's a simple way to memorize this formula, that what is here is what comes here before the fx. But there's something we need to recall, and that is the expectation of a constant. Remember, a and b are constants, so expected value of a constant is equal to that very constant. So either if you want the expected value of 2, it will be equal to 2. Then expected value of ax is equal to a. You first put out the constant followed by ex. Furthermore, the expected value of ax plus b, you first pull out the constant, multiply by the expected value of x, then plus this constant again, which is there. So these rules are very, very vital. So with that formula, now let's go to a question which can help us to memorize what we have learned in part C and the expected value of x. So question 3 says the probability density function of a random variable capital X is given by, so this is the function, then I said sketch the function fx, then part B Roman 1, find the value of the constant k, then Roman 2, find ex, and Roman 3, find e 3x plus 2. So the first thing to do is to find the probabilities or the value of fx for extreme values of x. For example, if you look at this function, this is what I mean by extreme values of x. These ones are extreme values, these ones and these ones. Therefore, I'll get the value of x of fx when x is -1, and also when x is 0, and also when x is 1, I'll use that. When x is 3, I'll use that. So I need f1, f0, sorry, f-1, f0, f1, and f3. So f-1 is k. So if you look at this, when I substitute -1 here, I'll come up with -1 plus 2, which is +1. So +1 times this gives you +k. But when x is 0 and I put 0 here, I'll realize that the value, I'll come up with 0 plus 2, which is 2 times k, to give you 2k. Then for 1, this one shows that it's a constant, therefore f1 is equal to f0. Then for 3, come and put 3 here, it becomes 5 minus 3 to give you 2. Then 2 times k over 2 gives you k. So that explains why you see these values here, that f-1 is k, f0 is 2k, and f3 is k. So now shall go and sketch our graph. First thing to do is to draw the axis and label the axis. The next is to plot. So when x is -1, fx is k, so we come at k and put there that point. When x is 0, fx is 2k, so we come at 2k and put there that point. Then you can join those 2 points to get a graph with a ruler. But remember to label the graph. The next, when x is 1, fx is still 2k, so you can join this point with this point to come up with that graph of 2k. Then when x is 3, fx is k, so you come and plot that point with this point and join using a straight line. So now we shall go to part B Roman 1. So for part B Roman 1, they wanted the value of k. So like we said, if the function of fx is entirely linear, you can also get the value of k, or the value of the unknown constant, using the area under the graph, that total area will be equal to 1. So in this case, this area of shape A plus area of shape B plus area of shape C must be equal to 1. So shape A is a trapezium, shape B is a rectangle, and shape C is a trapezium. So you must know the area of formula for area of a trapezium, formula for area of a rectangle, and formula for area of a trapezium. So for this case, this trapezium, the height is 1, which is h, then small a is k, which is here, then small b is 2k. So we shall come and say a half h a plus b, so it will be a half times 1, which is h, times in brackets a, which is that, plus b, which is that. Then for rectangle, the length is that and width is, the length is 1 and width is 2k, so it will be 1 times 2k. Then for this trapezium, the height is 2, then a is k, b is 2k, so it will be a half times 2 times in brackets 2k plus k. Now all that area must be equal to 1. So next is to simplify. When I simplify, this area is equal to 3 over 2k, this area is equal to 2k, and this one is equal to 3k. So when I add all these 3 areas, I must get 1. So when I do that, I realize that the whole of this left hand side is equal to 13 over 2k, so it will be equal to 1. Now next is to make k the subject, and the value of k will be equal to 2 over 13. So basically that's what they wanted. Now let's see how marks can be awarded. So B1 for axes, well labeled. B1 for the first sketch, which is well labeled first graph. B1 for the next, well labeled, and another B1 for the last one, well labeled. Then M1 for this definition, drop area equal to 1, and this A1 is for the value of k. So now that we have got the value of k, we can go back and rewrite the given function by substituting k. So here we shall substitute was k where there is, and we shall put there 2 over 13. Here it was 2k, so 2 times 2 over 13 will give me 4 over 13. And here it was a half, so a half k will give you 1 over 13. So now we shall go to Roman 2. Roman 2, they wanted the expectation. So expectation is given by the formula that x f x, that's what you integrate. So when I multiply, so f x f x means that, but remember here they said all x means that you integrate for this function, and also for this function. Therefore for the first function it is here, so you integrate from -1 to 0. For this interval it is 4 over 13, so integrate from 0 to 1. Then for this function it is that, but remember we are each function we have to multiply by x. That is why here it was x plus 2, now you are getting x squared plus 2x, and yet it was only 4 over 13, now you are getting 4 over 13x, and here it was 5 minus x, now it is 5x minus x squared. Now before we go to the next slide, M1 is for this step, correct definition of ex. Now next is to integrate. So when I integrate, the first part gives me that, second part gives me that, third part gives me that. The next is to substitute the limit. So when I substitute this 0 here, substitute where there is x, I'll come up with this. Then where there is x, I substitute the lower limit, I'll come up with this bracket. That is for the first part. Now for the second part, where there is x, put there 1 to come up with this. Then where there is x, put there 0 to come up with that. And lastly for this part, where there is x, put there 3 to come up with this bracket. And where there is x, put there 1 to come up with this bracket. The next is to simplify further. So when I simplify further, this is that, and the whole of this box bracket is equal to that. But there's this 1 over 13 outside, so it is that. When I add all these ones, I'll come up with 12 over 13. So that was the expected value of x. Now Roman 3, they wanted e of 3x plus 2. You have to remember that e of 3x plus 2 is equal to 3 multiplied by ex plus this constant, which is 2. Therefore in the end I know ex is this, so I'll come and put it there. Then 3 is from here, then 2 is from there. So when I use a calculator, I'll come up with 62 over 13. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for integration, M1 for substituting limits, A1 for the value of ex. Here M1 for substitution and A1 for the value of the output. So that was expectation. I believe you have mastered expectation. Now we shall go to the next part, which is variance of x and standard deviation. So the variance of x is noted by var x. So when you see this symbol var x, just know that they mean variance of x. And it's given by the expression that var x is equal to ex squared minus ex everything squared. So I think realize that this here I'm putting brackets before the square, and here the square is on x alone. So you already know what ex is. It means expected value, but we don't know yet what ex squared means. So like I say, the easiest way to master the formula, look at what is here and put it there. So but in this case there is x squared here, so that's what I'm going to put here to come up with x squared fx. So that's what I'm have to integrate. Then when after getting ex squared, I'll come up and substitute here to come up with variance at the end. So you also need to recall that variance of a constant is equal to 0. Remember, under expected value, the expected value of a constant was that very constant, but in variance it is 0. Then also var of ax, where a is a constant, is equal to a squared. Know that why there is a squared of var x. Also var of ax plus b is equal to ax squared, a squared var x. I think realize that here we do not add b because b was a constant and variance of a constant is always 0. So that is part D. So then we shall go to part E. Part E, so we are going to combine this and this into one question. So standard deviation, what you need to know is that it is the square root of variance. So with that, let's go through question 4. So question 4 says the probability density function of a random variable capital X is given by, so this is the function. Then they said part A, sketch the function fx. Then part B, Roman 1, find the value of the constant k. Roman 2, find the variance of x and hence standard deviation. Then part C, find var of 3x plus 2. So just start with Roman 1, where they want us to sketch. So the extreme values, f0 is 0, f1 is 2k, and f2 is k. Now that we know the function, the values of fx for the extreme values, we can come and draw our graph. So first label the axes, then you can sketch for the first part to be fx equal to 2kx, and the second part will be fx equal to k in brackets 3 minus x. So basically that's what they wanted. Now let's go to part B, Roman 1. Roman 1, they wanted the value of the constant k. So whenever they want the value of the constant, you have to remember that total probability must be equal to 1. But in this case, since our fx has entirely linear functions, we can also get the value of the unknown constant using the area under the graph. So in this case, this A is a triangle, right angle triangle, and this B is a trapezium. So the formula of area for right angle triangle is half base height. So base is 1, height is 2k. So that's where the half 1 times 2k is coming from. For this one, height is 2 A is k and B is 2k. So that's where the a half times 1 times open brackets 2k plus k is coming from. But that's be equated to 1. The next is to simplify. The whole of this will give me 2 over 5k, therefore k is 5 over 2k, therefore k is 2 over 5. So that means that we can rewrite our function by substituting for k. So where there is k, we put there 2 over 5 to come up with that, and this one we put there 2 over 5 to come up with that. So basically that's what they wanted. Now let's see how marks can be awarded for part A and part B, Roman 1. So B1 for the first part of the graph, B1 for the second part of the graph, M1 for the correct definition, A1 for the value of k. So now we shall go to Roman 2, where they want the variance of x. So we shall remember that variance of x is given by ex squared, which is that minus ex everything squared. So when I substitute, first of all, I don't know ex yet, so what I'm going to do, I'm going to first get ex alone. So ex alone is equal to, whether if this is just x, here it is also x alone. So when I substitute, fx will give me this for the first part of 0 to 1 and this for the second part of 1 to 2. Then I integrate to come up with that. So integrate this to give you that, this to give you that. Now when I next is substitute limits, so substitute 1 to come up with that, substitute 0 to come up with that, substitute 2 here to come up with this bracket, substitute 1 here to come up with that bracket. And in the end I'll come up with my ex as 17 over 15. Now that we have got ex, we can now go ahead and calculate for variance. So remember, variance was given by this minus mean squared. So this one means that fx is multiplied by x squared. So when I do that, I'll come up with this for 0 to 1 and this for 1 to 2. And this one we already got it as 17 over 15, which will be here. So when I integrate, I'll come up with this for this part, this for this part, and this one f square, I'll come up with that. So if we go to the next slide, let's see how marks can be awarded. So M1 for integration and substitution, M1 for value of ex, M1 for definition and integration. The next will be substituting limits, so I'll come up with that, and when I simplify, I'll come up with 97 over 450 as the variance. Then for the hence part, they wanted standard deviation, so it is square root of variance, which will give you 0.4643. And Roman 3, they wanted val of 3x plus 2, so val of 3x plus 2 is equal to 3 squared val x. I think we realize that we don't add the 2 because variance over constant is 0. Then when I substitute, I'll come up with the answer as 97 over 50. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for substitution, A1 for variance, then B1 for standard deviation, M1 for substitution, A1 for variance. So we'll go through another question. So that is question 5. Question 5 says the output of 9 machines in a factory are independent random variables, each with probability density function given by that. Find Roman 1 the value of A and Roman 2 the expected value and variance of the output of each machine. Then hence or otherwise find the expected value and variance of the total output from all machines. So a is a constant. I think you remember that for a constant you have to remember that total probability is equal to 1, or total area is equal to 1. So in this case we are going to use the concept of total area, total probability being equal to 1, where we use integration. So that means that fx of all x must be equal to 1. So from 0 to 10 it was the function of ax. From 10 to 20 the function was a in brackets 20 minus x. So we have to integrate those ones and equate them to 1. When I integrate this, I'll come up with this, I'll come up with that. Then substitute the limits and then you simplify to come up with the value of a. So the value of a will be 1 over 480. So basically that's what they wanted. Now let's see how marks can be awarded. M1 for definition and integration, substitution of limits and value of constant a. Then they wanted x mean and variance. So we shall start with mean, which is, if here there is x, we will put only x. So substitute x fx for from 0 to 10 is that, and from 10 to 20 is that. Next is to integrate. When I integrate, this gives me that and this gives me that. And when I substitute limits, I'll come up with this for that and this for that. And when I use a calculator, I realize that my value is 25 over 12. So that is the expectation. Now let's go to variance. So before I go to the variance, M1 for integration, M1 for substituting limits, and A1 for output. So variance also is given by this formula, ex squared minus ex everything squared. So when I substitute x squared fx for 0 to 10 is that, and for 10 to 20 is that, minus this which you got in the previous slide. So next is to integrate. When I integrate, I come up with that, and when I substitute the limits, I'll come up with that. So next is to simplify by using a calculator to come up with variance being equal to 2875 over 144. So that is variance. Now let's see how much can be awarded before we go to the hence part. So this one for integration, substituting limits and output. Then for the hence part, remember the total was 9 machines, therefore the total expected value will be 9x, and this will be equal to 9 times ex, but we saw that ex is 25 over 12, so in the end we'll come up with 75 over 4. Then variance, remember if this is 9 here, it should be 9 squared. So in the end I'll come up, when I substitute, I'll come up with 25875 over 16. So A1 for expectation total, and M1 for substitution, and A1 for out total variance. So now shall go to the next part, which is mod of x. So this is the value of x in the given range of the random variable of x for which a derivative of the function is equal to 0. The special case is that if the graph, if fx is linear, then the mod can be got by graphical method, and it will be the value of x corresponding to the highest probability on the graph. Then we shall combine mod with median, so into one question. So median is the value of m in the given range of the random variable x for which the integral of fx from negative infinity, now this one means lowest limit up to m, which is the median, must be equal to a half. Then also the special case is that if the fx is linear and is symmetrical about a certain value of x, then that value of x will be your median. So it is metric about x equal to a, it means that a is the median. So with that we can go through this question. So this question says a probability density function is given as, then that is the function, then they said find part A, the value of the constant k, part B, the mode of x, and part C, the median of x. So let's start with the value of the constant. So you shall remember that integral of fx for all values of x must be equal to 1. So fx, substitute for fx, then you integrate, then you substitute the limits and simplify, then make the subject and to be equal to a quarter. Now we shall go to Roman 2. Roman 2, they wanted the mod, so mod, we shall remember that derivative of fx must be equal to 0. So fx was this, so we are going to differentiate it. When I differentiate it, I'll come up with this, but remember it has to be equal to 0. So now next is to make x the subject. So when I simplify, I come up with that. Therefore x is equal to plus or minus 4 over 3 square root, which gives you plus or minus 1.1547. Now those are two values, but one value has to be eliminated. How? By looking at the range of the function. So the function is varied for values of x ranging from 0 to 2, meaning that outside this range it is not varied. Therefore when you look at these two values of x, one has to be valid. So in this case the positive one is within this range, so it will become your mod. Now another word for mod is most likely value. So when they can either say find the mod of x or find the most likely value of x. So both mean the same. So M1 here is for definition, and integration should be at that point. M1 for substituting, limits, and A1 for output. Then here M1 for derivative, and according to 0, then A1 for the values of x, both values, and A1 for eliminating to come up with the required value which is needed. So now we shall go to Roman 3. Roman 3, they wanted median, so we shall say let m be the median. Therefore the probability from 0 to m is equal to your median. Remember 0 was the lowest limit in this given function, that is why you put it there. So we are going to integrate from 0, which is the lowest limit, to capital M, which is the median of this fx, and it should give you a half. So when I integrate, I come up with that. Substitute the limits, so substitute m here to come up with this, substitute 0 here to come up with 0. Next is to simplify. So when I put this for this side, I'll come up with 2 here. Half times 4 is 2, which is that. Then multiply throughout by 4 to come up with that, and rearrange to get an equation of degree 4 to come up with that. Then we can now use bulldozer to get m squared first. When I use bulldozer to get m squared first, the values of m squared will be this and that. But they want the value of m, so I have to put square root on both sides to come up with that. So for the given range, which is from 0 to 2, it implies that the median is positive 1.0824. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for definition of median, M1 for integration, M1 for substituting limits, B1 for getting values of m squared, and B1 for getting values of m, and A1 for concluding. So that has been continuous PDF. Now we shall go to continuous CDF, or continuous cumulative distribution function. So the continuous CDF of fx. So not the case now. For continuous PDF we use small f of x, and continuous CDF we use capital F of x. So always note the case of the f being used. And this one, continuous CDF, is given means this probability of x less or equal to x, meaning it is cumulative probability. So we shall start with individual probabilities. Now under continuous PDF, for you to get individual probabilities, you are required to integrate. But for this case, if it is continuous cumulative, we no longer integrate. What we do, we only substitute. So this involves substitution of given limits into the CDF. So always remember that. Most students confuse PDF and CDF. So for PDF we integrate, but for CDF we only substitute. But the note on inequalities is still the same as that of PDF, because this inequality the same as this means the same as this inequality, and also this means the same as this inequality. But because it is only substitution, this probability now will not be got by integration. We shall just substitute. We begin by the upper limit, the highest value, which is that, and then minus the lowest value, which is that. So always remember that. So these one probabilities mean the same, this, and this, as we saw under PDF. But how to get them is what differs, because here we no longer integrate, we only just substitute. So let's see how this concept can be used. So a continuous random variable x has a cumulative distribution function. So this is how you can distinguish PDF and CDF. They will always specify that this is a PDF or this is a CDF. But if they don't specify there, then look at this case of the f. For cumulative, f is a capital letter or an uppercase. For PDF, f is a small letter. The another way to distinguish is at this last entry. So here for PDF, here it has to be 0, and here it should be elsewhere. But for cumulative or for capital F, the last entry is always 1, and here it is x greater than this value. So those are the three ways you can distinguish between PDF and CDF in a question. So now that you have realized that this is a cumulative distribution function, we can go ahead and answer the question. So part A, they want you to find the value of k, which is a constant, and hence sketch the graph of capital Fx. Then part B, they want you to find Roman 1 this probability, Roman 2 that probability, and Roman 3 that probability. So like we said here in capital F, we do not integrate. So how do they get the value of k? The value of k, you realize that the two functions have similar values of x. For example, this 0 lies in this function, and also this 0 lies in this function, meaning that when you substitute this 0 here and substitute this 0 here, they will be equal. Similarly, if you go to 2, this 2 lies in this function, and also this 2 lies in this function. So when you substitute 2 here and 2 here, the outcome must be equal. And also this 3 lies in this function, and this 3 lies in this function. So when you substitute 3 here and 3 here, they will be equal. Now the one which is easier to use, the first one is not easy because this is 0 and this is also 0, so it cancels everything. Then you can either use 2 or you use 3, but the easier one is to use 3, because here for this other function it is already 1. So we are going to use 3. So when I use 3, I'll substitute in the second, which is that, and the third one it was 1. So I realize that I have only one unknown, which is k, and when I simplify, I'll come up with 3k equal to 1, therefore k is equal to , 1/3. So when I rewrite the function of capital Fx, I realize that now where there is scale, I'll be putting there 1 over 3. So this gives me 1 over 6x squared, and this also gives me 1 over 3 in brackets 6x minus x squared minus 6, and this is still 1. So rewriting is advisable because we are going to still use this function in the preceding parts of the question. So M1 is for this substitution and A1 for the output. Then for the hence part, they wanted us to sketch. So end value is of 2. When x is 2, f2 is equal to 2 over 3. Therefore, we shall use those values to make our sketch. So we have to sketch all these functions. So the first one, x less than 0, is 0, so it is 0. But for this one, from 0 to 1, it is 1 over 6x squared. Now this one is no longer linear. This one is a curve, and it's a quadratic curve. So how do you know the shape? For you to know the shape, look at the sign on this quotient with degree 2. So for degree 2 here, the sign is positive. Because it is positive, it means it has a minimum value, so the shape has to be in that form. So we shall use that form. Then for this one, the quotient is a of x squared is negative, meaning it must have a maximum, meaning that the shape will be of that form. So note that one, that this one curves going this side and this one curves going that side. That is the way you can distinguish between these two, as we are going to see in the sketch. So for 2 corresponds with this. Therefore, I think realize that because this is positive quotient of x squared, it will be in that form. Then from there, between 2 and 3, because the quotient of x squared is negative, it will be in this form. Then from 3 onwards, it is 1. So that was the hence part. Now we shall go to part B, Roman 1. So part B, they wanted the probability of x greater than or equal to 1 but less than 3. Like I said, under CDF we only substitute. So we begin with the highest, which is this, minus the lowest, which is that. So f3 is 1. If you look at this function, this 3 here, the corresponding probability is 1. Therefore, you come here and put your 1 there. That is why this 3 is this one. But what about f1? So for f1, you look for where 1 lies. So 1 lies here between 0 and 2. Therefore, we are going to use this function. So put 1 here to become 1 over 6 times 1 squared. That is why you see here 1 over 6 times 1 squared. So when I simplify, I come up with 5 over 6 as my required probability. So that's what they wanted. Now let's see how marks can be awarded. So B1 for access were labeled B1 for the first part, B1 for the second part were labeled, and B1 for the third part, which is also well labeled. So now we shall go to Roman 2. Roman 2, they wanted this probability. And remember, this is this slash means it's a conditional probability. Therefore, we must get the intersection. So the intersection of this one is got by first sketching a number line. So for example, in number line 2.5, so this is 2.5, they said less, so it will go this direction. Then there is also 0.5, but they said it is greater, so it goes in that direction. Now if you shade, the common part is this one, the one which is shared by both, and it starts from 0.5 up to 2.5. That is why you see this probability. Up is the new intersection, which starts from 0.5 up to 2.5. That's where this is coming from. The denominator is what the probability after the slash. So after the slash, it is x greater than 0.5. That's why you put here probability of x greater than 0.5. The next is to remember the definition that here we substitute. So we begin with the highest value, which is that, minus the lowest value, which is that. Then here x greater than 0.5 means that this is the lowest value, but the highest is the maximum in the given function. So when you go back to this function, you realize that this is the highest, the rest is one throughout. So we shall come and say that the highest is a 3. Now next is to substitute where there is x, we put 2.5, but within the corresponding ranges. For example, if you look at this, let's start with 2.5. So 2.5 lies in which range? 2.5 lies in this range between 2 and 3, and the function in that range is 1 over 3 in brackets 6x minus x squared minus 6. So that is the function you have to use to get f 2.5. But 0.5 lies in this range between 0 and 2. Therefore the function to use is this, and that's why we're going to substitute your 0.5. So when you go back here, that is why here when we are substituting for 2.5, we get this, and when you're substituting for 0.5, we get that. Then f3 already know it is 1, and 0.5 already know it is that. So when I simplify, the whole of the numerator gives me that, and denominator gives me that. And when I divide, I'll come up with 21 over 23. So that was Roman 2. Now we shall go to Roman 3. Roman 3 is still a conditional probability. We have to get the intersection. So the intersection here, first of all, like I said, you have to get something like a number line. So 1.5. 1.5, they said x greater than, so it goes this direction. But you also have 2.5 and 0.5. So between this, there is that up to there. So what is common will be this. And when you look at it, it starts from 1.5 up to 2.5. That is why you see here the probability starts from 1.5 up to 2.5. For the numerator. For the denominator is the probability after the slash. So after the slash there is this. That's what we put here. The next is to remember the definition for CDF, but that we have to substitute. So 2.5 is that, 1.5 is that, 2.5 is that, 0.25 is that. Then when I use a calculator, I realize that this, the whole of the numerator is that, and the whole of the denominator is that. Then when I divide, I'll come up with 52 over 87. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for the numerator, M1 for denominator, and A1 for the output. M1 for numerator, M1 for denominator, A1 for output. So now shall go to median of x. So median of x, this is the value of m in the given range of the random variable x, for which fm is equal to a half. I think you realize that we are only substituting as long as it is CDF. When integrating, we have already altered the concept, so we only substitute under CDF. Then part C is how to obtain capital fx from small fx. So sometimes you can be given a PDF and they tell you to obtain a CDF from that PDF. So when you're given a PDF, just know that the CDF can be got by integrating that PDF cumulatively. Now this word is disturbing and can only be understood as we do the examples. So when you do the examples, you find out, you'll be able to understand what this word integrating cumulatively means. For now, let's leave it like that. So we shall go to question 8. Question 8 says the probability density function small fx of the random variable capital X takes on the form shown in the diagram below. So this is the form, takes on this, and it's a linear graph. Determine part A the value of the constant k, part B the expression of the PDF of x. Then part C, Roman 3, this is Roman 3, the expression of the CDF of x, and Roman 4, the median of x. So we shall start by getting the value of the constant. Remember, this graph is linear, therefore the constant can be got by saying total area equal to 1. So total area is a half base height, which will be equal to 1, therefore k is equal to 1. Then for Roman 2, they wanted you to get the expression of the PDF. So PDF is got by getting the equation of this line. No, this is the equation of it. This is a straight line. And remember, when you have straight line and you have 2 points, you can be able to get the equation of that line. For example, now in this case, we know this point, which is k. Sorry, it is 0k. This is 0k. And you also know this point, which is 2, 0. So when I have 2 points, 0k and 2, 0, I can be able to get the equation of that line by saying change in y over change in x, equating the gradients. So I'll come and use this concept of change in y over change in x. So the equation will be y minus 0. So we have remember we had a point 2, 0, and also a point of 0k, and we have already got that k is equal to 1, so the point is 0, 1. So when I use 0, 2, when I use 2, 0 and xy, I'll come up with y minus 0 and x minus 2. And also when I use 0, 1 and 2, 0, I'll come up with 1 minus 0 and 0 minus 2. So when I simplify, I'll come up with that, and therefore our function of small f of x will be equal to this, which is this, for this range from 0 to 2, and that means that elsewhere this function is not varied. That's why you have to put 0 elsewhere. So before I go to the next slide, let's see how marks can be awarded for this slide. So M1 for the definition, A1 for the output, M1 for equating gradients, B1 for the linear equation, and B1 for stating the expression of fx. So that was small f of x. Now we shall go to capital F of x. How do they get capital F of x? Remember we said we integrate cumulatively, but what does that word mean? So let's start. So first of all, this is our fx. And the values of x are from x greater than 0 up but less than 2. So that means that else outside this range, the function is 0. It is non-varied. This function is non-varied. Therefore, for x less than 0, the function is 0. And also for x greater than 0, the function is 0. Therefore, what you are going to do, we are going to come and say that for x less than 0, the function is 0. Now, I think we realize that we have changed the variable from x to t. Why? Because this is to help us to easily integrate the given function, because if we leave it as x and also integrate up to x, it becomes confusing. So here we are going to see how changing the variable is beneficial in the next part, but for this part just know that because this is 0, fx will also be 0. But for this range from 0 to 2, the function is, it was a half x minus 2 minus x, but because we have changed it to t, it becomes 2 minus t. Therefore, our fx, remember we said integrate cumulatively, so what we do, f0, so substitute 0 in this expression, we will still get and put it there. Then you integrate from 0 up to a variable x of 2 minus t, this half is here. Now when I integrate, I'll be able to come up with this, and when I substitute the limits, I'll come up with that. So this, I think by now you can realize why it was better to change the variable, because this one and this one, it will be hard to distinguish them. But now that we first change the variable, it is easier to distinguish the expression before integration and the expression after integration. So always it is advisable to first change the limit, first change the variable, so that after integration the required variable comes up. Then after this we have to also get f2. Now f2, substitute where there is x put 2 to come up with 1. Now always the very last value will always give you 1, the very last value in the intervals. This function had only one interval from 0 to 2, therefore the last value is 2 and must give you 1. If it doesn't give 1, it means that the probability is not equal to 1, and that means there is an error somewhere. Therefore for x greater than 2, the function is 0 because it's outside the range. Therefore capital Fx will be equal to f2, which is 1. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for integration, B1 for output, B1 for value of f2. Therefore capital Fx, shall come and conclude that capital Fx is given by that. So for x less than 0 it was 0, between 0 and 2 it was that, and greater than 0 it was 1. So always for cumulative the last value here must be 1. So now we shall go to Roman 4 where they want the median. Remember, median is given by substituting a value m, so let m be the median. Therefore when I substitute this m, we substitute here to where there is x put there m to come up with that. Then we can solve this a quarter, and that one gives you 2. Then you rearrange, this one goes this side, become positive, this one goes this side, become negative, which is that, and this is positive too because it's already on that side. Now that is a quadratic, you have to solve it, and when you solve it you'll be able to get to values of m, but 1 will be in the given range. So within this range the value is that, so, and that becomes your median. So this will be discarded and you take this as your median. So basically that's what they wanted. Now let's see how marks can be awarded. So B1 for that, M1 for definition, M1 for solving, and A1 for median. So now we shall go to obtaining small f of x from capital F of x. So sometimes they can also give you capital F of x and they tell you to obtain the expression for small f of x. So in the previous question you have seen how to obtain capital Fx from small fx, but in case you are given capital Fx and tell you to get small fx, it is the opposite. In the previous part we are integrating, so in this part we shall differentiate. So question 9 says a continuous random variable capital X has a cumulative distribution function, which is that. I think you realize that the last entry is 1, so that's how you can distinguish between CDF and PDF. So this, because this is 1, it means that this is CDF. Then part A they said find the value of the constant lambda, and part B the PDF, which is small fx, and part C expectation of x. So that means that we have to differentiate each term. Differentiate 0, you get 0. Differentiate this and also differentiate that. But before that they told us first get the constant lambda. So here we shall say this 4 is here and also this 4 is here. So that is the word we shall use to help us. Therefore we shall come here and say that f4 is equal to this and also equal to 1 for both functions. For the first function, remember the first function was lambda x cubed, so put where the x, put that. For the second one, it was just 1. So that means that lambda is equal to 1 over 64. Then we shall go to part B. Part B, you have to differentiate each term. So the first term will be that, and the second term will be 1. When I differentiate, it will be 0. Therefore, I'll come and say that small fx is equal to 3 over 64x squared from 0 to 4 and 0 elsewhere, because this was 0. Now we shall go to part C. So for part C, they wanted ex. So expectation of x cannot be got when you still have a CDF. So if you are given a CDF and they ask for expectation, then you have to first change the CDF to a PDF by differentiating. Then after changing it to a PDF, it is the PDF which you will use to calculate the expectation. So in this case, we have got this PDF, and that's what we are going to use to calculate the expectation. So the formula still remains. When there is x here, you remember to put x there. So when fx gives me that, and when I integrate, I'll come up with that, and when I substitute limits, I'll come up with that, and the end I'll come up with 3 as the expectation of x. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for substitution, A1 for value of lambda, M1 for this first derivative, another one for this other derivative, B1 for stating the expression, M1 for definition, M1 for integration, M1 for substitution, A1 for output. So that has been continuous CDF. Now we are going to go to the last part of this video, which is continuous uniform distribution function. So if a random variable capital X is said to be uniformly distributed over the interval of this, that means from A to B, then it implies that its PDF is given by this formula. So the formula is 1 over B minus A, where B is the highest value and A is the smallest value. You can also get it from here. B is the highest and A is the smallest. So this is the format in which a uniform distribution function is written, and A and B are called parameters of the distribution. Now, since the function is constant over the given interval, the graph of fx is a horizontal line parallel to the x-axis as shown. So I think to realize that this, when they try to draw the graph of a uniform distribution, it will be a horizontal line over the given interval from A up to B, and the function is given by 1 over B minus A. So let's go to individual probabilities. So if x1 and x2 are within this given interval of A and B, are enclosed by those two values A and B, it implies that the probability from x1 up to x2 is given by the integral from x1 to x2 of fx with respect to x. I think we already know that, but we know that fx is 1 over B minus A, and the whole of this is a constant. Therefore, when I integrate, I'll come up with this multiplied by this multiplied by x. Then when I substitute the limits, where there is x, put there x1 to come up with that, and where there is also x, put there x1 to come up with that. So what we are doing, we are deriving the formulas that are used under uniform distribution, because unlike PDF and CDF, for uniform distribution the formulas are derived and they always have a standard format. For example, when they ask for mean, it has its own formula. When they ask for probability, it has its own formula. When it asks for variance, mean, variance, median, standard deviation, the formulas are standard. So we are going to first derive all the formulas, then list their summaries, and after that we shall go through worked examples. So next is mean or expectation of x. So the expected value of x for the continuous uniform distribution is given by that. So xfx, where there is x, we put the x here. So when I substitute for this, I'll come up with this. When I integrate, I'll come up when I integrate here, I've not yet integrated. What I've done, I've only pulled out the constant. So the constant is 1 over b minus a, which is that. So I remain with the variable inside the integral, which is x. After that, I can now integrate to come up with that. So this x gives me a half x squared. Then I'm going to substitute for the upper limit here to come up with this, lower limit here to come up with this. Then this half goes outside, that is why you see these two there. Then I remember that this numerator is difference of two squares, so that's why this, you see that and that difference and sum. Then you realize that this one and this can cancel to remain with a plus b over 2. So always this is a standard formula for mean of x, and this is the standard formula for probability of any two values within the given parameters of a uniform distribution. So next is variance of x. So variance of x is given by the formula that variance is equal to ex squared minus ex everything squared. So we know ex in the previous slide, but ex squared is not yet known. So what we are going to first get ex squared. When this is x squared, here is also x squared. So when I substitute, I'll come up with that, and when I integrate, I'll come up with that. So next is substitute limits to come up with that. So this one is an identity that can be factorized to come up with that, and this can cancel to remain with this. After that, I'll come and say that therefore variance is equal to ex minus ex everything squared to come up with this. So next is to put everything under one LCM, which is LCM is 12, so you'll come up with this expression, and when I simplify, I'll come up with this, and from this I realize that this one, the numerator, can be simplified to become that. Therefore, this is the standard formula for variance of x. Like I said, we are still deriving the formulas, and after that we shall go through the questions. So standard deviation is the square root of variance, so you just get the square root of variance, and that will be your standard deviation. And lastly, median. For a continuous distribution, median value m over random variable x is got as follows. So still you integrate from the lowest limit to capital M and equate to 0, and equate to a half. So our fx is that. So when I integrate, I'll come up with that, then substitute the limits, cross multiply, collect like terms, and then make m the subject. So that is those are the expressions. So in summary, this is how you can get the probability of any two values of any given range, and so you can get the mean. This is what you use to get the variance, and this is what you use to get the median. So I think you realize that these two formulas are the same for expectation and for median, meaning that median and mean are the same for uniform distribution. So with those formulas, we shall go through question 10. So question 10 says a continuous random variable x, so this should be x, has a rectangular distribution, which is that. Find Roman 1, this probability, Roman 2, expectation, Roman 3, variance, Roman 4, standard deviation, and Roman 5, median. So we shall start with Roman 1. So in this case, negative pi over 3 is x1, and pi, this one is x2, Then b minus a, we said it was pi, therefore 1 over b minus a is this one, which is 1 over pi. Then x1, substitute for x1 and also substitute for x2. Then in the end, all of this in box bracket will give you 2 pi over 3, but there was 1 over pi here, so this pi and this pi cancels. You remain with 2 over 3. Now for Roman 2, they wanted expectation of x, so ex is equal to a plus b over 2. So a is this and b is that, divide by 2, so that's what this half is. You realize the answer is 0. Then Roman 3, they wanted variance. Variance, b is a half, b is pi over 2, which is that, a is negative pi over 2, which is that, and this 12 is here. So in the end we'll come up with this, which gives you pi squared over 12. Then for Roman 4, standard deviation is square root of variance, so we'll come up with that. And last, Roman 5, median, which is the same as mean, and it will be equal to 0. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for substitution, A1 for output, substitution, output, substitution, output, substitution, output. Remember, a third cannot be left in the denominator. So at this point, if you leave your answer at this point, it will be not okay, because the denominator is square root of 12, which is not okay. So you have to rationalize so that the third can go in the numerator. So here, substitution and output. So now we shall go to question 11. Question 11 says, given that a continuous random variable capital X has a rectangular distribution with mean of 3 over 2 and standard deviation of root 3 over 2, find the probability distribution function of X. So here we are given mean and standard deviation. So first of all, you know that mean is equal to a half of b plus a, so and it was given as 3 over 2, therefore we are going to get an equation having b and a. Then you also know that variance is 1 over 12 of b minus a squared, so we shall equate it to standard deviation is the square root of variance, so that's why there is square here to get variance. Therefore we shall also get another equation of having a and b. Now those are two equations and two unknowns, meaning we have to solve them simultaneously to get the values of a and b. So before we do that, let's see how marks can be awarded for this slide. There is b1 for equation 1 and b1 for equation 2. So solving the two equations, I'll first add equation 1 to equation 2 to come up with that, meaning that b is equal to 0 or b is equal to 6. Therefore from equation 1, when b is 0, a will be equal to 3 minus b, which is 3 minus 0 to give you 3. And when b is 6, a will be equal to 3 minus b, which is 3 minus 6, and gives you negative 3. But remember, for a rectangular distribution, b must be greater than a. Therefore, if you compare this and this, it is impossible because b is smaller than a. But for this other pair, this and this, it is okay, meaning that a is negative 3 and b is 6. Now that I've got a and b, I can come and get my expression of fx, which is 1 over b minus a, to give you 1 over 9. Therefore the probability distribution function can be written as 1 over b minus a, which is 1 over 9, and here it is a, which is that, and here it is b, which is that, and elsewhere it is 0. So that's what they wanted. Let's see how marks can be awarded. So M1 for addition, B1 for both values of B, and here both values of A, and here concluding, getting the function fx, and here setting the expression of fx with 0 elsewhere seen. So So now we shall go to question 12. Question 12 says the number x of cars crossing the Owen Falls Dam daily is uniformly distributed between this and this. That means that this is A and this is B. Roman 1, find the probability that at least 1625 cars cross the bridge. Then Roman 2, what is the expected number of cars that will cross the bridge on any day? So just start with Roman 1. At least means that or more. Therefore the expression will be probability of x greater than or equal to 1625. Now that means that this is the smallest, and that becomes your x1. Now x2 will be the highest, and the highest is this. Therefore when you are substituting, you'll put this here and this there. Then b is this and a is that. So in the end I'll come up with 1400 over 1999 as the required probability. Then for Roman 2, they wanted the expected number, which is ex, and it's equal to a plus b over 2. So a is that, b is that, divided by 2 to come up with 2025.5. So m1 will be for substitution and a1 for output, m1 for substitution, a1 for output. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on normal distribution. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on normal distribution has been uploaded. Otherwise, thank you for watching, and also if you know any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.